So dear students, today we'll be discussing about chemical kinetics. So let me share the screen. So mainly we'll be doing the numericals today. Let me come back to this. Yeah. We'll go to the end of this thing. Yeah. First thing, let us take, important numerical in this is this. I think you guys can see this question, right? Question number 13. The rate of reaction of increases by something, correct? By 4 times and all of those things, correct? So this question, we got only one formula. There is log of K2 by K1, EA by 2.303 R, T2 minus T1 by T1 T2, where T2 will be always our higher temperature, T1 will be lower temperature. Very easy question. Don't get afraid by seeing these kind of things. Okay, can you see here rate of reaction increased by what? 4 times. Correct? Okay, so this K2 by K1 will be 4. I'll just tell you how to compare between the problems. See the rate of what the ratio of the rate constants of the reactant. Rate constants is K2 and K1 is what? 2. So K2 by K1 is what here? 2. Let's take one more question. Can you see here? The rate constant of a reaction is doubled. Doubled means K2 by K1 is equal to 2 again. So you got the idea, right? So normally it will be doubled 4 times, 9 times, all of those things. So K2 by K1 will be 9. So just like that. The rest everything is kind of same only. Okay. Rest everything is kind of same itself. Let me just close this system screen. Yeah. So EA is called what? Activation energy. So if you know the formula, then we will just fill everything. And R is universal gas constant 8.314. I'll fill it where? Here. I told you higher temperature and lower temperature. Just fill it here. That's it. And what is my log 4? Log 2 square. Log 4 can be written as what? Log 2 square. Log 2 square. That is basically 2 log 2. I already know what log 2 value is what? 0.3010. Correct? So 2 into 0.3. That is 0.6. That only they written down here. 0.3010, just for clarity. For every question, it will be log 2. So you obviously will study 0.3010. Then just do the multiplication and you'll get it. Simple as that. Okay. So if I want just to come to the next question, what is it? Log of K2 by K1. Again, same thing. What is the ratio of rate constants of reaction is what? 2. So K2 by K1, 2. Put log 2 is equal to what? 0.3010 respectively. Then higher temperature and lower temperature. Just substituting everything. Then find EA. Whatever is it, put into joules. This is not kilojoules, it is just joules. So these documents I'll be sharing you later. So this is one important question which can come for 3 marker. Activation energy, simple questions. Again, if you want in the class, physically also I'll explain to you. Okay, so don't worry about this. So this is only for students who is unable to attend the session today. Yeah, then coming to one more type of reaction is first order and zeroth order reaction. Let me take, Let us take this question. The fourth question, as you can see here, no, it's not that clear. Calculate the half-life period of first order reaction. Half-life formula is what? T half equal 0.693 by K, which you derived. Correct? And rate constant is K. So put K value here, 6.93 into 10 power minus 3. Just do the calculation, that's it. Again, in calculation, if you got doubt, feel free to tell me or ask me. in person, so I'll help you out on the same. The next question again, same thing, T half. Formula done. Then again K. Formula done. That's it. Yeah. See this question. A first order reaction is 50% complete. Correct? In 2 hours. It's not clear here. In 2 hours. What is the time required for the completion of 80% of the reaction? So first thing is the rate constant given? No. But what is the T half given? 2 hours. In the question it is there. 2 hours. It's missing here actually. 2 hours. That's the thing. So first find the K. Then first order reaction formula. Just put the formula. K T is equal to 2.303 by K log of initial concentration to the final concentration. So initial concentration will be always what? 100. Final concentration will be what? 100 minus how much it is the thing? 100 minus 80. That is just 20. So put 20. Again, compare and study. The next one is what? 75% of the reaction. Correct? So 100 minus 75 is what? 25 here. 30 minutes. Put T is equal to T half is equal to 30. Compare and study. See again, let us take this question. This question anyway, they asked us to calculate R, but I hope everyone understood. R naught will be always 100, R will be subtract. This 80% means 100 minus 80, 20 remaining. That's how we get 20. Correct? So once we cancel this thing, I'll get log 10 by 2, log 10 minus log 2. Log 10 value is 1. Log 2 value is what? 0.3. So simple substitution. And K value, how do you find? For the first order reaction, it is 0.693 by T half. Simple thing. If you know the derivation properly, you can do the problems just like that. Same thing, 75%. And those who are worried about the anti-lock, today I'll be teaching it in the class when this is over. And then coming to, yeah, the next type of question. Show that for the first order reaction, this is T 87.5% 3 times 50%. Correct? So first thing is what? For the T 87.5%. First thing is rate constant for the first order reaction formula, which you derived, put it. 2.303 by T log of, what is R naught? Initial concentration 100. By what is my R? If it's 87.5, subtract 100 minus 87.5, 12.5. Correct? We know that 125 into 8 is what? 1000. So 12.5 into 8 is 100. So 8. 8 can be written as what? What is 8? Log 2 cube, right? This is my log 2 cube. It's not clear here. Yeah. Log 2 cube. Log 2 cube. So that is basically 3 log 2. 3 into 0.3. So 3 into 0.3 is 0.9030. That's it. Okay. So you get T 87.5 as this. And T 50%, half-life, the formula is already known, 0.693 by K. Then divide equation 1 by equation 2. We'll get the ratio. Once you get the ratio, that's it. Substitute and that's it. Done. Okay.